Hello, ladies and gentlemen. This is Mr. Green. I'm recording this Algebra 2 lesson. We're going to talk about the forms of linear equations. So, can we talk lines? Okay? We're going to actually look at the forms of linear equations and convert between a couple of them, and then graph equations of lines in a slope-intercept standard form and in a point-slope form. So, we're going to look at all three of those things and see what we can come up with. Okay. Linear equations. Linear equations have the following characteristics in common. There is no variable with an exponent greater than 1 or 0. So you're only going to see an x or a constant in it, okay? Or a variable and a constant. You won't see two variables in them. Now, the variables are not multiplied together ever, okay? It is possible to write the equation without any variables in a numerator of a fraction, okay? And the graph of the equation is in a coordinate plane. It is a line. That's what you're going to be looking at. So let's look at some of them. There are three forms. The first form is called the standard form, okay? Standard form is where you say a constant variable ax plus by equals this constant. So you're looking at a very, very standard format of thing. Why do they call this standard form? Well, it's just the name they gave it. Please, I didn't come up with it. It's just the name they gave this format right here. Ax plus by equals c. A and B are all A, B, and C are all integers. A and B are not zero. You can't have zeros in either one of those two places. Now the slope-intercept form, y equals mx plus b. Why do we call it the slope-intercept? Because right here, m is the slope and b is the y-intercept. So y equals mx plus b is the slope-intercept form of an equation. Now, in this one, m slope, b is the y-intercept. Okay? Point slope form. Point slope means I've got a point and a slope. Well, where's the point? Well, there's an x value and there's a y value. That's my point. x1, y1 is the point that we're going to be looking at. And m is the slope once again. So x1, y1 is the point that we're going to be looking at. I want you to notice, see the negative sign here? Minus, minus. It is always minus, but the x1 is a positive number. Okay, so you'll be converting those. You kind of do that conversion in your head when you're doing it. So let's look at some of these. If I'm given something like this, that is the standard form. How do I know? I've got constant variable, constant variable, constant. Okay, 4x plus 3y equals 15. That is in constant form. We want to write that in slope-intercept form. Okay, so to write that in slope-intercept form, we've got to make some changes to it. Right? Well, in slope-intercept form, my y is on the side of the equation all by itself. So what I'm going to do is I'm going to subtract 4x. Why am I subtracting the 4x? Because if I subtract that 4x from both sides, I'll get the y located by itself. This is what I call the Clooney rule, because George Clooney always tries to get his girlfriends alone before he breaks up with them. Okay? He never tries to do it in public. So 3y minus 4x plus 15. Now I pulled a little bit of a trick there. I swapped the order. It's called the commutative property. I didn't write down the equation 15 minus 4x and then the commutative property to swap the order. So I did skip a little bit of a step there, but you all can see that it does work out to be this value. Now when I want y, I don't want 3y, I want y. So that means I've got to divide by 3. I'm going to divide the whole thing over here by 3. So this becomes y on this side. And using the distributive property, if I'm dividing by 3, I've got to divide both sides or both parts of this equation up here by 3. So I'm going to say minus 4 over 3x plus 15 divided by 3 is a 5. So what's my slope? My slope in this situation is minus 4 over 3. What's my y-intercept? My y-intercept is 5. Easy to graph it when I've got that information available to me. Okay? Let's go look at another one here. If I were to want to take this one here, this one is in point slope format. Why? Because I've got a point sitting here. There's my x, -7, my y, 4. I'm going to write that down. x1, y1 in this situation is going to be -7, 4. Where'd you get the -7 from, Mr. Green? Well, notice how it's got a plus sign here? Remember I told you it had to be a minus, so that means it had to be a -7 in this particular situation. So we want to write it in standard form. Well, standard form is where I've got ax plus by equals c. So what I'm going to have to do is I'm going to have to move some things around. So one of the things I'm going to start with is I'm going to start with the distributive property. I'm going to take this 1/5 and multiply it times both of these two right here. So I'm going to get y minus 4 is equal to x over 5, that's 1/5, plus 7 over 5. Okay? Well, I want to get this 4 out of here. Okay? And I also want to get rid of these 5s down here. I know what I'm going to do. I'm going to multiply this whole thing here by 5 using the multiplication properties that I know I can do. And I'll multiply this side by 5 as well. That'll get rid of those 5s, and I'll be left with 5y minus 20 is equal to x plus 7. Now, Mr. Green, couldn't you have just multiplied it by 5 up here on this one, up here, and gotten rid of it? Yeah. You know what? I didn't see it to begin with. Does that mean what I did was wrong? No. I took a step and then took another step, and it wound up at the same spot, didn't it? That's one of the things you can do in algebra is you can take those steps and maybe you'll get to the place you want to. Maybe you have to do something slightly different. Well, what I'm going to do now is I'm going to subtract the x from this side because I want it to be on the other side of my equation here. So I'm going to get 5y minus x minus 20 equals 7. I'm going to add 20 to both sides of the equation. And I'm going to get 5y minus x equals 27. Now I'm going to pull that commutative property on this other side over here because I want the x in the first front. So I'm going to get minus x plus 5y equals 27. There it is, standard form. What's my a? Well, a in this situation equals a -1. What's my b? b in this situation is equal to a 5. And what's c? c is equal to 27. Well, that was pretty easy. I didn't see any difficulties there. Just a little bit of algebraic manipulation. Let's take this one. Point slope to slope intercept. Oh, this one ought to be easy because we've already got the slope in here, right? So what I'm going to do is I'm going to say y plus 2. Well, I know I've got to get rid of that 2 somehow. But what I'm going to do is I'm going to do the distributive property over here to begin with and get 3x minus 12. Now, why did I do that? Why did I do the distributive property first over here? Because I know that I don't want this 3 outside in parentheses. I want it to be extended so that I can take this 2, subtracting the 2 from both sides, and get this y is equal to 3x minus 14. And I've wound up with my point slope, my slope intercept here. My slope in this situation is 3, and my intercept is going to be at -14. That's what we do when we're just doing these little bitty manipulations. Okay? Okay. Slope intercept. If I want to graph it, well, what I'm going to start with is this right here, -3. That means it's going to be right here. 1, 2, 3. I'm putting a point right there at -3. Okay? And then I'm going to take and do the slope. Okay? Slope is rise, so I'm going to go up 1, over run 2, 1, 2. And there's going to be my second point right there. Now, I'm going to take a line. I'm not real good at doing this without some guessing here. And I'm going to take my line and I'm going to draw it through both those 2 points. Okay? I did a very poor job of that. Try it again. Just like that. Okay? Somewhere between those 2 lines that I drew there. But that is what we would be doing to get to graph this one. Nope, the other one. The other one. That one. Delete. Thank you. Okay. So that's how you would graph something when you get point, slope, intercept. You start with the intercept and then you put the slope in place and you usually wind up with a good line for it. Let's try another one. This one, they want to graph this using 2 different methods. One of the things I'm going to do is I'm going to take this and convert it into a method that's really easy to graph. First one, I'm going to make it into slope intercept. So I'm going to say 4y is equal to negative 5x plus 6. All I did was subtract the 5x from both sides. I'm going to divide by the 4, and I'm going to get y is equal to negative 5 over 4x plus 6 over 4. Well, 6 over 4 is 1 2/3, or 1 1/2. 1 1/2. So that means it's going to intercept right there. Okay? My slope is negative 5 over 4, so I'm going to go down 5. 1, 2, 3, 4, 5. And I'm going to go over 4. 1, 2, 3, 4. There's my other point. And I'll draw my line between those 2. Just like that. Okay? Well, let's look at another way of doing this one. Okay? Let's put it into, let's put it into point slope form. Okay? Well, I'm going to come and start with this one right here. 4y is equal to minus 5x plus 6. What could I do? I know what I can do. I can subtract 1 from this side, like this, and I would get 4y minus 1, minus 1 is equal to minus 5x plus 5. What I get when I do that is I can pull the minus 5 out, and I get minus 5 times x minus 1 is equal to 4y minus 1. Well, now I can then divide by 4, right? If I divide everything by 4, I'm going to wind up with y minus 1/4. It's equal to minus 5 over 4 x minus 1. And where's my point located? Well, it's going to be located at 1 comma negative, or 1/4. 1 comma 1/4. That's where my point is located. See here, I got a 1 and I got a 1/4. So let's look at where 1 1/4 is. 1 1/4. Looks like it's right there. That's a pretty good place for it there. My slope is negative 5 over 4. That's exactly what I had graphed before. And so that's the way I would graph it using a point slope method. I used 2 different methods to graph that one. Okay? Let's just graph this one in point slope format. Okay? Where's my point? Well, I see a plus 3, so that my point is going to be at negative 3, comma 2. I'm going to go to negative 3, 2, negative 1, negative 2, negative 3, 2. It's up 2, 1, 2. There's my point right there. My slope is 4, so I'm going to go up 4, 1, 2, 3, 4, and over 1 right there. And that's where my line is going to go. I'm going to draw my line, put it here. And I go from there down to there, like that. And I would draw off my mouse pad. So that's the way it would look. Easy enough to draw these things, isn't it? Okay? So when we start looking at linear lines, one of the things you'll notice, y equals mx plus b. Any changes to the m or the b will cause changes in the graph. If you change the m, it's kind of like rotating it around, isn't it? Kind of moves it around in different directions. But it would stay centered at if the b stayed the same, it would stay centered at the same place. Now, one thing I want to have you notice is the smaller the number here, the lower the graph is, the lower the rise, the less of a slope it has. If the number gets bigger, it gets steeper up this way, closer to vertical. Okay? When numbers start going negative, that's when they start going this direction, down this way. Okay? So you've got to have positive is sloping up and to the right, negative is sloping down, going to the right. Now, if I left the slope the same but changed the b value, it simply translates the line, moving it up and down. So it shifts it up and down. This one rotated it by changing the slope. Changing the b causes it to translate a little bit. Okay? Don't forget your homework. It's always in this lesson resources. It's always talked about in there. And it's in the Algebra Reference Guide on pages 57 through 60. You do not have to turn those things in. You don't have to worry about the dog eating them, but you do need to do them, because if you don't do them, you won't do well on the quizzes. So you need to do the homework. If you have questions about any of them on the homework, bring them to the TOGA sessions. Bring them to my Class Connects. We'll talk about them during those time frames. Okay? When you're communicating with me, make certain you tell me what course you're in and what section number of the course you're in. I have multiple courses and multiple sections, and so finding you sometimes is easier to get the right information so that I can answer your questions better, okay? So that's all I've got for you today. I'll look for you next lesson.